All right, and we're COMP123, and it's week 3, lesson 3, part 3. Right, part 1 and 2 was yesterday, part 3 and 4 today. So let's take a look at some some questions in the morning as we start off. So people had some questions, I'm sure, about object-oriented programming. We covered that yesterday a little bit. We're going to go back into the what we talked about yesterday. I'm just going to relaunch. I'm going to go through my virtual machine now and relaunch it for a second. And while this is starting up, I'm going to talk about our PowerPoint presentation we kind of did yesterday in terms of some of the challenges that some of you would have, right? Remember we talked about a class being a blueprint of almost like a mini program that runs inside of your main program, right? And that it can be replicated many times. That's the idea behind it. And as it's replicated, each of its new objects can contain their own properties that are individual, that are different from every other object. So if I make, like maybe we use the house analogy, if I make, if I have a house blueprint and I make, the plans for the house, I can build multiple houses from the same blueprint, but each house that I make, like actually create or build, right? It's like my construction crew out there, they're different houses, right? Why? Because they live on different lots. Let's look at the property. So each property is different, memory locations, right? Each, the way the house looks, even though it's very similar, there are slight differences, right? Because each house is slightly different. They have different values, right? Some houses are different colors on the outside or have different bricks or whatever. But at the end of the day, they're still houses, right? So when we look at objects that are created from a class, the shape of the object is based on the shape of the class. But the values of the object, hear me out here, this is abstraction. We're talking about abstraction again here. The values of the object can differ and are going to be maintained differently across different objects. So again, I can have house 1, 2, 3, 4, 5 to infinity, as much as your computer can take, right, as an example. And each house can have different values for each of their properties that are shared. All the properties are the same properties that every house has based on my blueprint, but each value could be different slightly. So think about hexadecimal values for color, right? Now I know guys, we only see in 16 colors. Girls, they have more sensitivity, right? That's what the rumor is anyway, right? So if we only see 16 colors, but the girls see in 32 colors, right? There still could be 32 different variations of houses for sure, just based on that. Right, if we're just doubling the amount of sensitivity in terms of color, right? So, so the houses are the same. They're the same, made from the same blueprint, but they're different in terms of value. And that's how objects are in many ways. Same thing with objects, for example, that are from the car analogy. Even if I make the same make and model for the cars, right? As an example, if I was going to go with the car analogy, each car, right? I mean, my car compared to your car has a different VIN number, right? So therefore, they're different. My vehicle identification number would be different from one car to the other. That's the value that's stored in the VIN property. If I had a VIN property, vehicle identification number property, right? Then the value for the VIN property for each of the vehicles that I made, even if it's the same make and model, are different. And so therefore, each object can be differentiated. So that's what I wanted to kind of review with you guys, just so you guys are up to date with that. Because one of the challenges always is for students who are learning about object-oriented programming for the very first time is, I don't get it. I don't get this whole idea of objects. Why would I use an object? I can just do procedural programming. What's the advantage for me to use objects in classes compared to just writing things procedurally and just with a bunch of methods? Well, the great thing is, imagine if I'm creating a video game, and I think I go back to that. I fall back to that because it's easier for me to understand too, right? So if I go back to a video game and I have your hero, and one of your main assignment here, assignment number 1, is based on this hero class you're going to make. It's a very simple one, by the way. But, the hero is going to fight a bunch of enemies, right? Now imagine if I was doing it procedurally. right? I'd have to create the enemy over and over and over and over again. And I'd have to rewrite a lot of code. Potentially some of the hurdles in terms of calling the enemy again and again to create his properties or their properties would be very challenging, right? I can get around them. I can do it procedurally, but the lines of code would be much more than if I did it with using a blueprint like an object or a class. Think of it this way. Once I create my enemy one time and I have all of his values, the ability for him to move, shoot, defend, do whatever, right? I can replicate this enemy. I can clone it. I can clone the object over and over again as many times as I want. So I can always spawn these new enemies, and they'll have the exact same properties as they did when I first created them. You can kill one enemy, his health, which is a property, will go down, and I'll destroy him. But meanwhile, there's other enemies, which is the exact same enemy as the other one. It's a clone, right? Will live and fight independently, right, of the enemy that I created based on the enemy class, right? So each object, that's another thing to know, is independent of each other object. The only thing that can make them dependent, or if you will, the same, is when you have static properties, which I mentioned last time. To me, is not a great idea unless you want them all to share something. Like, for example, a good static property for all objects to share, right, is let's say you want each of the objects to be numbered. Okay, they're all numbered. And let's suppose that there's an array, right, an object array, that was a static array, right, so that it was shared between all the objects. So when you instantiated a new object, you would actually increment the array, right? So in each array, each object would have its own number, right, as an example, if you wanted to keep track of each object for whatever reason. That might be something that you might want to do. But again, very complex. And when you think abstract thinking, it's like over some people's heads. They're like, what is he talking about, right? You need to use this stuff in order for you to understand it to some degree. But I wanted you to, I want to review it with you again and again. I want to talk about it with you, right? So that the language that we're talking about, you get used to when we talk about objects and classes and what the differences are. Before I get into constructors, which I think is, again, a very key point in our discussions around objects and classes, I want to do a little bit of quiz work. So let's do that. So let's start off with this one here. Okay, and you can log into this one for yourself. For those of you smart people who are recording this, because maybe it's going to be on an exam or test, all the power to you. Using private fields within classes is an example of blank, a feature found in all object-oriented languages. I have one information hiding. A couple of information hiding, a few. This is just to perk your brain up this morning since it's just after 8:30. You're not allowed to talk to him. Oh, go ahead. That's right. Again, so A, information hiding, B, polymorphism, C, inheritance, and D, overloading. That's good. We got a bunch of answers. 17. You guys are logging in and doing your thing. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 people in the class. 18 answers so far. We got 7 more people, and then I will shut it down. I want all of you to try and answer this one. If you do think it's something else other than information hiding, by the way, you can certainly put it up there. I'm not keeping track. But I think that's enough. I think 20 of you out of 25 think it's information hiding. And I can't hide the fact, no pun intended, that it isn't anything but A. It has to be A. We talked about this yesterday at length, actually. We said when, I just shut it down, by the way, using private fields within classes, we want to information hide, and it's a key, a feature of object-oriented languages because we don't want to show the guts of the engine. Okay, I don't know if I can say it different ways. The guts of the machine, right? To the users of our classes. We just want them to use our classes, right? So we hide the stuff we don't need them to see, right? We don't need them to see the guts of the thing we're making. We just want them to use the thing and use the methods and the properties, right? So we use information hiding to take away the stuff that they don't need to see, that's not important for them to see, and put it away, and we keep it private. It also makes it easier for us to, when we create classes, so they don't clash with one to the other, and we'll talk about that later on. Okay, let's go to the next one. If you don't write a constructor for a class object, C# writes one for you, right? I got a few answers here, right? If you don't write a constructor for a class object, C# writes one for you. We haven't taught constructors yet, right? But I want to see how many people are up there. 16, 17. Very, very good, guys. You're on the right track. I'll stop it now. For those people who haven't answered, it's okay. Okay, one more. Oh, who said false? You ruined it for us. We almost had a perfect record. If you don't write a constructor for a class object, it's true. C# will write it for you, but it'll write the empty constructor, which means you can't put anything in there. When we write custom constructors, our own constructors, we can, well, as you'll see as we come forward, we can, what we can do is we can write custom properties and parameters that are inside of each of the constructors that we create, right? And we'll talk about that as well. Constructors, all right? If I talk about a constructor, think about it when I initialize the class. If I instantiate my object, as soon as I do that, in order for me to instantiate or build my objects from my classes, it has to go through the constructor first. It's almost like the first step that it has to do. When I build the program, I also build the constructor first. It's like the first thing that gets built. It gets constructed, right? So my build goes through the constructor, and anything that's inside that constructor method fires, which means it goes. So as soon as I build my object, the constructor method is called right away, right? First, before anything else happens. So if I want something to happen right away when my object is created, I put it inside the constructor. Okay? That's what a constructor is. We'll talk about that in a bit. Here's the next one. The data components of a class that differ for each object are stored in A, instance variable, B, states, C, instantiations, D, relationships. The data components of a class that differ for each object are stored in blank. And what do we mean by those things? So when we talked about data components, think about them as, the values that are stored, right? We talked about, I just actually talked about it before I kicked off this poll here a couple minutes ago, right? I'll wait for a couple more answers. States. Okay, let's see. 17. Oh, we got a little bit more responses now. 22. Okay, that's good enough. It's really, oh, there we go. Just got under the gun. 23 responses. I would say definitely instance variables is the way you go. Instance variables is where all of our data is stored that makes it different for each object. So if I have properties, strength for my hero class, health, speed, or my car, I have a make, a model, a color. All those things are the different things that happen. The values of those properties are what makes them different from one object to the other, right? Even if they're identical, if I make two objects and they're absolutely identical in terms of make, color, model, blah, whatever, they're still different because of the way they're stored. Their memory locations are physically different. They're two identical clones living in two different memory locations. Think about them as physical things that you're creating, breathing life into these things. Last one. If you do not provide an access specifier for a class field, its access is blank by default. I got a couple of internals. I got a public. This one's a tricky one. Public. We're going to check this out together. I'm going to try this out and see what happens. I got a couple privates. This is where it's, we have to look at this thing together. And this is where some of these questions I like and some of them I don't like, right? You have the answer?
I Googled it. Alright, close it out.
No problem, no problem, no problem. So I've got, 22, 23 answers so far. And you know what? The majority of you are all wrong. Oh, yeah. That's what I'm saying. It's tricky, right? I'll stop it now. The answer is private, actually. That's what it says in the book, right? So let us, the best way to do that is check it out and see if it's true, if the answer is actually private, by actually testing things out. So let's test it out. Let's go back to our little class we created, right? Because again, if you're not specifying the access specifier for a class, the class itself, right? So the class field. Now, look what it says for a class field, not for the class field. Field, property, instance variable, blah 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 blah. They're all the same, right? It means the property itself, right? Let's check it out and make sure that it's correct, right? And this is where, the stuff in the book and the test banks, we have to make sure that they're correct, right? So I'm going to go back into Visual Studio here. I'm going to relaunch it. I'm going to go back into our little project that we were working on yesterday, COMP123 lesson 3, right? Some kind of beeping going on. All right. I'm just going to maximize this thing and go down. So here I've got some public modifiers, right? Public, public, public. I did it a bunch of times here for a reason. Well, now what if I just don't specify anything? So I'm going to make a new, modifier here, and I call it, so I've got for my car, my make, my model, my color, my speed, and you know what? I want to make an integer value for a VIN number, or maybe I'll make that a string as well. So string, I'll call it VIN, right? Vehicle identification number. That's what it's going to stand for, and I'm not going to specify an access modifier, right? This is the question we just got asked, right? I'm going to go back to my program here, and when I try and access it, so here I got my new object, which is called my car, and we looked at the code hinting. If I go my car dot, can I see my VIN number? Right? So this is an example of the default values for all properties are private unless otherwise specified, right? It's good and bad. My question to you would be this: should you specify a value anyway? Right? And my answer would be for you, for the people that are here and willing to answer or listen, yes, I think it's better to be explicit and not assume anything. When you program, okay, you guys are fledgling programmers or coders, if you will. Some of you might have experience doing other things. My take on it, and again, I've been doing this for a while, right, is better for you not to assume anything, all right? If you assume that the program is going to do something because you're letting things implicitly happen, right, there could be chances of logic errors, which means you think something's going to happen one way. It's not a syntax error. It'll run, but it won't give you the right results, right? So please, I recommend to you, unless otherwise, if I tell you otherwise, or if someone else tells you otherwise, assume that you should specify everything. Be specific. It's funny though, some of the newer languages like Swift, Apple's Swift, there's a lot of data inference, right? Data type inference. And there's a lot of implicit stuff that's going on with Swift. And the reason for that is because they say, you know what, if you're a programmer and then if the language is written a certain way, and if it's written right, it should know what you're trying to say, right? So to make your life a little easier. For now, because you're starting off, until you write you're in another kind of language, even in C# here, I want you to use the this keyword everywhere, right? When you specify, when you're pointing at your properties or your instance variables, and the methods that are inside classes. If you're calling the methods from the class inside the class, use the this keyword. I want you to get used to it, right? Because if you do, the advantage for you is that when you move to another language, you're safe. You're good, right? The syntax in your mind will be the same. if you use this keyword. You're not going to go wrong if you do it. Some languages will not need you to do it, but others will. So if you use this keyword all the time, you can program in all the languages, right? It's not going to hurt you. If you forget to use the this keyword, it's okay, right? But the problem is sometimes you confuse which variable you're pointing at with your value. So that's the one thing. So if I want to make this, let's go back. So if I go to the car again, so here's my string, my VIN, and if I make this public, right, as an example now, if I change this to public and I go back to my my car and I press dot, right, and I want to look for VIN, well, there it is. Right, so you see, it was private by default. Now it's public because I made it public, and I can put in my vehicle identification number. Well, let's keep that because it's definitely something we want to talk about here, right? It's definitely a public property for now. I may make it private again. I'm going to move this back in here underneath the public properties area, right? Because I've kind of specified that all these properties are public properties, right? And if you notice my commenting here, I've got a couple of comments. And one of the comments I haven't put in is a comment for the car class itself, which is probably something I want to do, right? You know, car class, blueprint for car objects, basic stuff, right? And sometimes what you want to do, you may want to do a lot more details here than this. We know what a car is, but if you don't know what a car is, that's an issue. I'm getting an error, and the reason why is because I've left this half open here, right? Which is I don't need. But I could do like my car VIN, and maybe I put in a series of numbers, like, you know, and letters. So it's a V 325 B6, whatever. I'm gonna make a bunch of just random letters here, numbers, right? So that's what VINs look like, kind of, and they have a certain pattern, which I'm not going to go into. But let's just say that's my VIN number, big long letters and numbers. And we can make a scheme for that thing. You know, we're looking online and kind of get a pattern for the VIN numbers, no problem. But for now, let's make it random numbers. Okay, that's cool. So I've got my car class, and everything else is working. The one thing we don't have in our car class right now is a constructor. And we're going to talk about constructors right now. All right. So what is it? It's a method that instantiates an object. I don't like that. It's really a method that runs. I think this is the way to go. It runs or is called when the object is created. That's the better way to say it, right? And the default constructor, it's automatically created even if you don't put one in. And it's the empty constructor. We talked about that before. I'll repeat that again. And the value of an object initialized with the default constructor is the default value of the object. Yeah, not sure if I like that either when we talk about the value of an object. But really, the constructor itself creates activity. Think about it this way. If you go and once you create the object, it's a method, some kind of action that runs when the object is created. I think that's the better way to think about it for you. Once you think about it that way, I think you can consume the idea of constructors a little better in your mind, right? So what is this darn constructor thing anyway, right? So if you look at here, I've got my class employee, and then I've got this other method also called employee. It's the same name as the class, right? And when we call something that's the same name as the class, this is considered the constructor. I'm using the same name, employee with caps. It's got to be the same spelling, right? And right now, this is exactly identical to the empty constructor, except that we're taking the pay rate, which is, and again, I don't see it as part of our class here, but we're saying pay rate is actually equal to public property. Here it is, and this is another bad thing. See how we did down here? We have up here in the top, we have some properties, private properties. We have a public property here that we have a getter and setter for. And if you notice, there's an empty getter and setter. This is another way to write a public property. But they put them down here, right? Bad. I don't think this is good programming practice. Myself, my recommendation to you when you program, to make it easy for your life, all right, is put all your properties at the top. before your constructor, if possible, right? And then, although, by the way, C# won't complain if you mix them up, right? You can mix properties anywhere you like. As long as it's inside these curly braces, you can put it in. But it's bad. It's not best practices. Best practice says that we put our properties at the top of our class. We use some comments to specify that they're public or private. And sometimes we'll even describe what they are if our identifier, our variable name, doesn't do it for us. Like, for example, VIN. You and I know what a VIN is because I just said vehicle identification number. If you don't know what it is, and if I don't want to write a long variable name, vehicle identification number, it's a long variable name to have in our code over and over and over again, I might put it in a comment, vehicle identification number, so that we know as a programmer what it is, right? In an inline comment, right? But again, I want to house all of my properties at the top, which means this public property down here should be, in my opinion, somewhere at the top of the code. And then your constructor, right? So when you look at this, you're like, pay rate, well, there's no pay. Oh, here it is, right? That doesn't make any sense to me, right? So pay rate, you're assigning pay rate $9.99, let's say as an example, right? And you're doing this, you're making the assignment statement inside the constructor. So what does this mean? What am I doing here? When I create my employee class, what happens? Let's go through it one by one. What happens to my as I go through? Go line by line. I create my employee class. I instantiate it. What happens? Do I have a value? Do I have a value for ID number? I'm asking you. Tell me. Do I have a value for ID number? Yes or no? I need it loud and clear. Yes or no? It's a yes or no. There is no other value. No. Good. What's about this one? Do I have a value for my string name? You're going to answer all these. Let's go. No. It's a good answer, right? How about this one? Do we have a value when we first kick off the class? We have a value for pay rate, right? Now imagine pay rate's up here, right? We're following it. We're following step by step, line by line. The answer is no. Not right away. No. But what happens when my constructor fires? I'm going to call this firing or kicking off, running, called, whatever you want to say it. What happens when my constructor fires? What happens when my constructor fires?
It applies that number to the pay rate.
Let's use assigns. It assigns, we'll use that word, okay? Assigns this value, this literal, to the pay rate. As soon as the constructor fires. As soon as the object is created, the constructor fires, whether you define it or not, right? And it'll do something to anything that's inside. So anything that's inside this code block, inside the constructor, it gets called. So now, if I have a value that's being assigned to a property, but what if I put a bunch of other methods in there? I could make a lot of method calls in here in my constructor, which means they'll fire. So if I want methods to kick off right when I instantiate my object, I put them inside my constructor. Okay, anything in my constructor will run, right, just as if it's being called. As if the method was being called when I create my object. That's why constructors are powerful, right? And this is actually one of the really cool things about objects. Thank you for answering. Yes?
What is the difference between a method and a constructor?
A method and a constructor? The constructor is a method, but it's a special method that runs when we instantiate our object or create, breathe life, build, I don't know, whatever you want to call it. We build our object. And we call it instantiation, right? But when we build our object, the constructor method is called right away, right? There's no choice, okay? If you don't define a constructor, it's defined for you. Let's try that out, all right? So here we have our car class. I'm going kind of slow here for you guys. I've declared a bunch of my public properties, my private properties, and inside here I'm going to create my constructor now. And again, if you look at the example, I have an access modifier here as public, right? You know what? What's the default value for my constructor? There's no void or anything like that. But what? That's just the return. But what about? And I can specify a return for my constructor if I want to, right? But what's my default value in terms of access modifier for my constructor? It has to be public. So even if I don't put it in here, it's automatic. If I make my constructor private, it'll error out. It won't allow me to. Let's try that. I'll show you why. If I go private, right, and I run car, right, and I kind of close it off like this. So I made my constructor private. It won't do anything. It's like the empty constructor won't ever get here. I'll never be able to do, put my car class in there. So this is kind of useless. Yeah, I could do it, but it won't give me the right results. What I really want to do, I'm just going to save this so you see what I'm talking about here, right? Look at this, right? Because I made my car private, I can't instantiate an object, right? Because my constructor has to fire. It has to be called, and I can't call it if it's private. It's not exposed, right, to the outside world, right? So I have to make it public if I want to call it. That's the one method you need to make public, right? If I'm going to call it outside of its class. So really, it's public. It's public by default, and it's okay to specify. And again, I would be explicit and say public. So here's a constructor, right, as an example. And if I want to, when I'm firing up the constructor, if I want to instantiate, or if I want to, initialize one of these properties, I can do that here. Like for example here, I said private int speed is equal to 0, right? Well, this is cool, but what if, and this is something that you see more often. By the way, let me just put some comments in here. This is how I would like you to do it. So constructor. You might have multiple constructors, by the way, right? Because remember, we talked about last week, right? We talked about overloading methods, right? Where you can have multiple methods, multiple constructor methods, if you really want to, that have different signatures. So one with 1 parameter, one with 0 parameters, one with 3 parameters, one with unlimited parameters, right? That's something that you can do there as well. For now, let's just put one constructor in here. If we had more than one constructor, I'd probably put constructors, right? And I might even specify what this constructor is. For example, this is the empty constructor, but there's no real reason to put that in there. It doesn't do anything right now. Actually, this is equivalent to what we were doing before, right? If you notice, it doesn't error out anymore. It works the same way. That's why sometimes you won't see this, right? So this is the empty constructor, right? It doesn't do anything, right? Here it is typing furiously, but I'm gonna erase that in a second. But what if I want to do something here? Well, I've got this speed that I'm initializing, right? So I'm initializing the speed to 0, right? And if I want to do it inside my constructor or somewhere else in my code, let's say I do it in my constructor. How would I specify, I'm just going to take my initialization here away, right? How would I specify that I want to initialize my speed? I'm going to ask you today. Tell me what would I do? Give me the code that I would put, the line of code that I would put in there to initialize my speed to 0. I love it. This dot speed, remember you could do speed is equal to 0, right? But I want you to use this dot speed, and if you notice it'll come up when I do that. This dot speed is equal to 0, right? Which is equivalent to me in initializing this. Inside the constructor, what this means, that when my constructor is called, this dot speed is equal to 0. If I initialize them here though, truly, once the object is created, they get initialized too, right? But here I'm specifically saying to you that this dot speed is equal to 0. I'm giving it a value as soon as my constructor is fired, right? This is cool and all, right? I like this, but I want to give some. I want to give these public methods, or public properties, make, model, color, and VIN. I want to kind of be able to set these things, right? So there's a couple ways to do this. One is I could make getters and setters. That's the traditional way of saying it. Or get accessor methods, like they say in the book, or set accessor methods, set accessors, to create this stuff, right? I could do that. That's one way I could do it. The other way is I could pass some of this stuff into the constructor as parameters. All right, so before we get there, let's read the PowerPoint and see what it says. I want you to see it, right? So here's the employee. Here's the parameter being passed into the constructor, right? So I'm saying my public employee constructor, I'm passing in a double rate. Oh, and this is where I get some weird stuff going on, right? Pay rate is equal to rate. Sometimes you'll see this. pay rate is equal to, and this is what we call pay rate. Pay rate is equal to pay rate. And you're like, what the hell? This is where you use this keyword. And that's why I'm telling you, to avoid confusion for yourself, use this all the time when specifying properties. Okay? Otherwise, so then in your mind you go, no, I want my instance variable, my property for my class to change. I don't want it's not just the value. I'm not taking the value and assigning it some other random value. It's the property inside the class. Okay, so this is what the constructor looks like with one parameter. So let's add that in. So I'm going to put in, I want to take the make, model, color, and VIN, right, into my parameters. So a bunch of parameters here. We're kind of jumping the gun. Well, how would I do that? I have to specify a data type. I don't have a choice. So string make, right? I'm going to use the same names, by the way, just to make it really confusing. String model, string, and the same order, color. Oh, if I make a mistake, it's bad. String VIN, right? So these are all the things that come into my constructor. And by the way, they're required now because I've created a signature for my constructor. I cannot instantiate an object without specifying each of these things here, right? If I call it like this, right? Then I say, hey, you know what? I need all of these things as part of my constructor. And what I want to do in here, okay? Help me out here. I'm going to ask you because you're in front of me too. So if I want to set all my make, my model, my color, and my VIN to my properties, how would I write them? Using these variable names that I've made. What would I do? So let's start writing together. You tell me the words. This, right, dot, yeah, is equal to, come on, take a guess. No. I want to take the value that's coming in from my parameter, and I want to assign it to my property. What do I put in there? Come on. Take a check. Make. This is where it becomes confusing. This is correct, actually, right? This dot model is equal to model, right? This dot color, right? This dot model, this dot color, this dot color is equal to color, right? And actually the code hinting helps you, eh? And this dot VIN, right, is equal to, and if I start typing, VIN is there, right? And if you notice, I can put in, I'm just going to put a little comment that says vehicle identification number. Right, that's my vehicle identification number. And you know what? Well, if I made them over here, right, my make, my model, my color, and my VIN, I put all this into the constructor here. And by the way, I set my speed down here too, right? Well, do I really need all these properties up here in this particular case to be public anymore? No. Unless I need to make a change or I need to read these properties somehow, right, by themselves, like give me the make, the model, and so on. And if so, I'm going to use get accessor methods for each of these properties. Keep them public, right, but don't allow them to be set again once the object has been created. If I make them only getters, that means I can only read the properties, the read only. I can't set them again. For now, let's just make them all private just to keep it simple. So I'm going to take the private keyword. I'm going to copy and paste it over top of the public keyword. And of course, when we do this, we don't have any public properties anymore. So I'm going to just remove all this stuff. I'm going to cut this stuff. And just for a second, I'm getting some errors. And I'm going to paste all this stuff over here because now they're all private properties, right? I'm leaving my public properties section empty for now, right? And if you notice, this is where I instantiate, or if I initialize properties via the constructor, right? Because I'm taking these properties, these parameters into the constructor, 1, 2, 3, 4, and then I'm initializing these things, these make, model, color, and VIN, and then my speed gets initialized to 0 because I just make it 0. It's not moving in the beginning, right? My car is stationary in this example. Okay, cool. Now I have a problem, right? I have a problem with my car class, right? even though I have the default empty constructor, unless I override it and create another default empty constructor that does something, I'm going to require all those things. Look, when I hover over it, it tells me my code hinting says, I need all this stuff. I need like a make, a model, a color, and a VIN. And if I don't have that stuff, it's going to error out. That's the only signature that I have available to me right now because I haven't created any other ones. Right? So now I'm forced, because I put those parameters inside the constructor, I'm forced to use them when I build my object. Right? The new object that I'm going to breathe life into, I need to have all that stuff. So let's put that in there. So instead of doing this stuff down here, mycar.make, mycar.model, mycar.vin, I don't need this anymore, so I'm not going to do that anymore. Right? I'm going to put it all in here. So make, obviously it would be Honda. Let's make it with a capital H just to be fair. Model, I'm in the model, and if you notice it highlights when I'm going to the next one, right, for my code hinting. My model is going to be a pilot, right? My string, my color is going to be black, right? And my VIN number, I'm going to make it, so for now I'm going to make it like 1, 2, 3, 4, 5, so it fits on our screen, okay? Obviously it would have to be a bigger number than this. Let's just add a character in there, X 1, 2, 3, 4, 5, how about that? Just to make it so it's a short little VIN. Because I haven't specified a minimum length for the VIN, and there's other things we can do to that. Now if you notice, there's no error anymore, right? There's no error here anymore because I specified each of these parameters inside the constructor, and this is what the constructor requires in order for me to create this object, right? Because I've only specified one signature right here for my constructor, which requires these 4 parameters. If I specify other signatures, then I'll have other abilities, right? Make, model, color, and VIN is initialized. Now that they're initialized here, I can use them further down. So for example, right now I have a drives forward, I have a set speed. You know, what if I want to show, right, show my car, I want to just kind of display my make, model, color, and VIN and speed right when my constructor is fired, right when my object is created. What do I need to do? I want to create a new method, obviously, right? But I want it to fire. I want it to be called right when my object is created. What do I need to do? I'm going to point at you now. Tell me. Yeah, you. Yeah. And sorry, your name is again?
It's Ronald.
Ronald. Thank you, Ronald. So, okay, so inside my constructor is where I'm going to put it. What am I going to call? Let's create the method together. You come up with a method that I'm going to create to display the car values, right? Call it whatever you like.
A new method, or can we just use like console dot?
You could. I want you to make a method though. Come on.
Let's create a method of display car.
So it's going to be called, remember, my car is going to be called car, and I'm going to go display car. Car.display car. Why don't I just call it display? Right? Or we might call it show, car.show. Or car. Remember, think about the car. If you're in your mind, I'm making my car dot and whatever the method is going to be. Tell me something that's useful. You can come up with anything else. I'll do whatever you tell me.
Let's use display then.
Display? For now, display is okay. So I say display, right? Well, if I do display here, there is no method called display, right? Now this will fire. This will display, and I'll put some comments, displays cars property values, let's say.
It's aired out.
What?
It's aired out.
It's aired out because there's no method. We have to create the method now, right? Now the method, this display, does it have to be public? Does it have to be public? The answer is no, it does not have to be public because I'm calling it within my car class. And is it right to call display, or should I use the this keyword? This is the right thing to do. I want to use the this keyword, even though it doesn't exist yet, to specify that this method belongs to the class. It's not a random display method that's coming from my generic functions or anywhere else, or some other built-in class, right? It's my display, this display here. Well, it's going to be a public method, so I'm going to put it in my my private method. I'm going to put it in my private method section, which is here, right? So here's set speed. Let's create a new one called display. So private void. It's not going to return anything. Display. And you know what? I'm not going to take any parameters. It's just going to be a utility method, right? And inside there, what do I need to do? Well, I'm going to do some console.logs, right? So I'm going to say console.writeLine. And maybe what we want to do is we're going to start kind of typing out this thing, right? So let's add some, just some separators. So this is my first, I'll create a separator. And then console dot, I'm just making this up, guys. You can make yours look whatever you like. Console dot write line, and then the next piece will be model, right? And I'll use the string interpolation. So we'll go this dot model, and you see it's available to me because even though it's a private property, it's still within the class. Therefore, I have access to it inside my display object, my display method, right? I'm going to do the same thing, but instead of model, it's going to be model, or make. Make should be first, right? Make, model, color, and vin, right? So all those different ones. I'm going to take this. Just making some stand-ins right now, and I'm also going to make this kind of have surrounded by this. So here's my make. Just going to do this differently, right? Color and vin, right? And of course, I've got to change these too, right? So this has got to be make, and as long as it doesn't error out, I'm good to go, right? This make, this model, this color, this fit, right? So whenever I call the display method, right? Oops, I don't want that. I'll show you that later. I'll say utility method to display car properties. That's all it does, right? So we kind of describe what the method does, right? Make sense? I'm kind of scroll down pretty quickly. Here it is, just for those people who haven't seen it yet. I'll give you guys a sec. I'll save this. Right, so this display method, lowercase, is going to fire, is going to be called. I'm just using different words for the same thing. As soon as my constructor, which is the same name as my class, okay? One of the requirements for a constructor is it's got to be the same name exactly as my class. Car is my class. My constructor is also called car. I've defined a signature, a parameter signature for my my constructor that takes 4 parameters: string make, string model, color, and vin. These are value parameters that are incoming. So I take the values that I pump into my constructor, and then from there I reassign them. I initialize them into my properties, and then from there I call a display object or display method to display my properties. Yes?
So does that creating the private properties as a class properties
Mhm.
can we declare the variables, the class variables within a constructor?
Well, let me answer this question. What is the scope of any variable inside of these two curly braces? So I've got these curly braces up here in the constructor, right? From here to there, right?
Within the constructor.
So if I declare a variable inside that constructor, or with any code block, what does it do?
It will be within the.
I think I want you to think of it like this, okay? When I say the scope, I want you to think of life cycle, all right? Think about I'm creating a variable. It lives and dies within that scope. Lives and dies, which means after you're outside of that thing, it won't be available, it won't be accessible, even if you make it public, whatever you want to call it, it won't be accessible anywhere else. And even if you do, you're breaking the rules of object-oriented programming, right?
So, I have a question because in a constructor is a special case of a method, right?
It's a special
So you
method.
wanna know if it's
No.
different or not.
No.
Is that-
It's not different. What you want to do is you want to make these, it almost looks like these properties here that are outside of any constructor or any method. It almost looks like they're global, right? In fact, they are. They're global properties for the class if they're private. If they're public, they're available outside of the class, right? So if I make properties inside of my class, if I make them private, they're only available, but they're globally available to any method within my class as long as I use safely the this keyword, right? And I recommend that you do, right? But if I declare a variable inside my constructor, it'll live and die inside of there. So if I pass these parameter values, make, model, color, and VIN, I don't have to do something with them here. I can call them make, model, color, and VIN, but they'll live and die in my constructor. I'll pass them in, and then they'll disappear.
If you declare it privately, like the class properties, is it accessible only within the constructor?
These? Are you talking about these things, or if a new property? Like if I declare a new property called, I don't know, we'll call this, I'll declare it, so I'll say private. I'm just going to try it anyway for you, right? And I'll call it, I'll make it a string, and this private string will be of type, I don't know, my string. Let's just use that for now. And I'll initialize it to hello, right? Okay. So here's my private string. Now, see this access modifier? See how it says, hey, I can't use my expression term private because I'm declaring a local variable, right? And so therefore, my access modifiers for a regular variable, private, public, and so on, are invalid, right? So I can't use this access modifier. Doesn't matter what I put, public, private, static, here. Public, right? That won't work. Protected. Right? Sure. I can't do that. The reason why is I'm declaring a variable, a new variable, within this local scope, within inside these two curly braces. That's the scope, inside the code block, right? If I declare it my own new property that's not outside of my any other method, like in this particular case, these properties swim outside of any other method. They're inside the scope of the class. See, they're inside these curly braces up here, underneath the class. As soon as I enter this scope and I declare a new property, it's not available anywhere but in this scope, right? So I can't use protected, private, public. I can't do that because it doesn't make any sense. The context for private, public, protected, and so on is only within the class scope. It doesn't work. It doesn't make any sense. It has no meaning with inside a method, right? So therefore, we can't use it. I can declare a string, right? And this string will work, right, inside inside of my constructor or any other method, right? It will work. This string, my string, hello, right, will work. But it'll live and die inside this method, right? So if I try and call my string, right, over here, and let's say my display method, right, and if I go this dot my string, well, my string doesn't exist. And if I just go my string, it doesn't exist. I can't find it. It'll error out. It doesn't know that my string lives and dies inside that constructor block.
So we have to use this keyword for initializing a variable in a method other than the constructor.
No. If it's a method other than the constructor, like for example, if I have a variable name and I want to initialize a variable inside my display object, it's impossible. You can't access it unless that variable.
It's private.
No, it's a local variable. It lives and dies within the scope. It's not public or private. It's just a local variable, and you have no access to it whatsoever. There's no access to local variables.
You cannot access the variables declared as a property of a class. You cannot initialize it.
No. If you okay, so this is the thing. There's different kinds of variables, right? These properties of a class can be accessed by any member of the class, including any method, right?
And if it's private.
Doesn't matter. Private and public are only how the outside world sees these properties, right? Inside the class, they're available. Private and public, they're available, right? It's only outside this class how these access modifiers function. However, and they're available to each of the methods that I declare, right? However, if I declare a special local variable, like I just did, string, which is my string, right? This my string variable, which is inside the constructor or any other method, it's not accessible to any other method other than the constructor unless somehow I link it to a property that's a class property somehow.
So the only two
Right.
differences between the constructor and a different method would be constructor has the name as a class, and constructor is called first.
So the question is, the only difference between a method and the constructor method is that the constructor is a special method that's called first, right? And it has to have the same name as the class.
That's it.
It has a return type as well if you want to use it. If you want to return something from the constructor, you could, right? Right now, the return type is what by default? Void, right? If I go public void car, right? That is the default return value for my constructor. However, what if I want to make it so that I'm going to make this my string? I'm going to do something with your string you made now, right? If I say, instead of my public void, right, I want to return a string value. I can do that, right? I can specify that the car returns a string value, but when I do so, it gives me an error that says, hey, you're missing a return value. And therefore, I'm forced, when I put a value, just like we do with any other method, to put the return keyword in here and return a value, like, for example, my string, right? And that would work, right? Now, if I go back out to my program, here's the problem. Car, my car is equal to new car. It says, error, it does not contain a constructor that takes 4 arguments, right? Right? Because look what it says here. My car, and I have 1, 2, 3, 4 arguments, and my car does not contain a constructor that takes 4 arguments. Why? Because, huh? Go ahead, tell me. Why? Because
it should return string data type, but
correct. Right? This is the wrong way to do it. Right? This isn't the right way to do this kind of thing. We'll talk about return types later on, right? But it's erroring out because this string type is wrong.
Because it already returns a reference type.
Correct.
If you return something else.
It returns whatever I want to return, right? I don't have to specify. Okay, so let's just we'll talk about that later on, right? I can if you notice, if I take out the return type, let's make it void for now, like it was, and see what if it causes a problem. All right, so if I make it void as a default and save everything and go back to program, I still get this error, right? Because it says, hey, car does not contain a constructor with just 4 arguments, right? If you notice, there's 1, 2, 3, 4. I don't understand. Well, we have this void in there, right? So let's go back out there and kill it. And when we go back, if you notice, it's good. Right, we'll talk about return types in a bit, okay? I want to be able to return something with my constructor, but it's not the right way we're doing it. Okay, so going back. So a constructor is a special type of method, right? The constructor fires or is called as soon as the object is instantiated based on the class, right? And the other thing is that the constructor, each constructor signature has to have the same name as the class. Okay. We talked about it being automatic, and constructors can be overloaded, right? And it says you can write as many constructors as you want as long as their argument lists do not cause ambiguity. We talked about ambiguity last week. If you have 2 different arguments and so on. So here's some examples of a couple of constructors or 3 constructors for employee, this employee class, right? And this is interesting. I have one that has just the employee ID, right? I have another one that just has employee and the salary, right? I also have another one that has some kind of code that I'm passing in, right? Whatever that code is. That's not being used, by the way, right? Here, I am using my employee ID as my ID number and my sal as my salary. I'm doing that. I'm assigning them. And if you notice, they're not using, in this particular case, all these examples are not using this keyword. So the answer is, do I have to use the this keyword? The answer is you do not have to use the this keyword. I'm telling you to use the this keyword for best practices, right? I would recommend that you use it in your coding, right? To take away your ambiguity of what you're pointing to, especially for beginning programmers, right? Otherwise, this is the biggest thing that people get confused with. What is it? How come I need to use this keyword anyway? And what is it pointing to? If you start using it all the time now, you'll understand what it is. If you don't use it now, you'll never use it. And then when it appears in your code, you're like, oh my God, what is it? Right? Use it all the time. You can't go wrong. Here's a default way of setting an empty getter and setter. I could declare every variable like this, get, set, get, set. These are just empty getters and setters, right? I don't have to do this, however. It's done automatically for me. So that's kind of useless. Okay. Let's talk about this overloading stuff. Well, here's some examples of, after I've created my 3 constructors for my employee class, this one, and this one, they're all different. So there's so my constructor has been kind of considered overloaded. I've overloaded my constructor with 3 different signatures. So I know I'm killing you guys with this stuff. We'll break in 5, right? Give you guys a break. We'll ask some more questions. And then here I'm calling the constructor. I'm creating 3 different objects based on the same class, employee, right? But I'm using the constructor 3 different ways. The empty constructor up here. I'm using this employee 234, right? And employee A with a string. So this is the ID, and this is the string value, right? And if you notice, when I write line, I can say a worker.id number, right, for my first worker. And for another worker, I can do the ID number and the salary, and I can set a toString. I can use the toString method of the salary method, salary property, to convert it to string and make it a dollar value. That's what C stands for currency, right? And the same thing was if I created the new one called the boss, which is another type of employee, 3 different objects, a worker, another worker, and the boss. They're all employee types, but my employee type is A. And I can also take that the boss ID number and the salary as an example, and I can assign them. I can print them out because if you notice back here, I set my ID number and my salary to $100,000, right? My ID number is 111 automatically, right? So even if I use my character code in here, which is A, it doesn't do anything. In fact, this character code that I'm passing in, this parameter, lives and dies within this constructor signature, so it's absolutely useless. Doesn't do anything. Goes in, and then it goes to the bit bucket in the sky.
This is a bad example.
Well, it's an example, but I think in this particular case, this parameter doesn't make any sense. We're not doing anything with it. Here, we're at least doing something with these ones, right? This one, you're not doing anything with at all, right? Because it's going in here, and then you're not doing anything with it. It's being destroyed after the parameter, the constructor fires. It's gone, right? Questions before we move on? I know I've talked about constructors a little bit more. Constructors are the main theme of today, all right? So yesterday we talked about objects and classes a little bit more. Today it's right around constructors. Constructors is the key thing. When you create an object, the constructor is called. It's fired, so to speak, right? When we fire the constructor, almost like think about when I say fire, think about a message firing off, right? It's sending a message that says, this is the real way it works. When I create or instantiate an object, a message is being sent, right, through the compiler that says, call the constructor. That's what it's saying. So that's why I'm saying it's fired. It's fired off. Like a trigger, it's triggered. Maybe the other way to say it, yes.
My question might be just an understanding question, but could you go back to the last screen? You said there were 3 constructors?
There are.
4?
1, 2, and 3. And now what about the empty constructor? Where's that? Right? Here it is, right here. Here's the 4th one. I missed that one, right? This is the empty constructor, but they've defined it as nothing. There's no parameters. Sorry, I missed that one. That's my error. This is the empty constructor, right? And that's why I like comments. And this, I guess, for the sake of space, they didn't put them in. But I would put a comment that says empty constructor. Here's a constructor with just the employee ID. Here's a 3rd one with employee ID and double. And there's another one with a useless character code that goes in and lives and dies, right? There's 4 different ones. And that's why when we go to this one, I can call the empty constructor up here and it works. Otherwise, if we didn't define it here, right, and I called the empty constructor, but I only had these 3, it would error out, right, because I haven't called it. Once I create my own custom constructor, the default constructor is destroyed. It doesn't get created, right? The default constructor is the empty constructor, right? But if I make my own, compiler says he doesn't need one. We don't make one for him, right? This one, I'm actually defining the empty constructors up here, and so therefore each of these things are valid constructors, are valid ways of creating my object. Okay. The only way my object is going to be created, I have to pass through the constructor in order for my object to be created. Right? The execution, the code, the way the code is run in order, the first thing it does is it says when I create my program, my little mini program here that's my class, I go through every property, right? And then every property is given allocated memory, right? And then my constructor is triggered. I'll use that instead of fired. It's triggered, right? And then if I don't have a constructor, it makes one for me. If I have multiple constructors, it only triggers the constructor that adheres to the pattern of parameters that my user, whoever the user is, sends into them. So if I have different kinds of a parameter signature, then it's going to fire or trigger the constructor that is the closest to the signature that is called. Right? If I call in, if I don't send in a double or an int, like let's say, for example, I send in a string here, in this particular example, it would error out. It doesn't know, there is no string. The closest one would be this character code here, right? Because that's the only one that takes some kind of character, right? And there's some really weird things it can do, especially in other languages. In some other languages, it'll try and hunt for the most likely constructor, right? And then it'll convert the value for you. That's bad. Imagine if you convert a value and you have an int, but you're passing in a float or something like that. It'll concatenate or chop off the significant digits. It's bad, right? So don't do that. I'm going to take a bit of a break in a second. Here's another word I want to stop with. I'll let you go with this one. Constructor initializer. It says a clause that indicates another instance of a class constructor should be executed before any statements in the current constructor body. Let's take a look at this, right? So here, all right, if you notice, here's the constructor initializers, right? So my public employee, and then I got this colon. This is the syntax. And after that, I have a number, 999, 0. Employee ID 0, right? And then 111, 100,000, right? Okay, this is very interesting. And if you notice, it says this keyword is being used every time, okay? What's really happening here, right? What's really happening here? The empty employee, this follows, if I say this, funny enough, what it does is initializes each of the properties in order. Again, I don't like it. It's not a very nice way of initializing stuff, and it leaves some ambiguity. It doesn't. You don't know what's happening. It's not explicitly telling you which of the variables here, which of these instance variables or class properties, I'll name out, or fields, whatever. I'm going to call them the same, different things, so you understand they're all the same word, right? They all mean the same things. It doesn't specify which one gets what. And if you notice, employee ID, it says take the employee ID that I'm getting in here from my constructor and assign it to ID number. And then, you know what? I don't have a number for my salary, so assign it as 0. Right? These are called constructor initializers. I can choose to use them, or I can choose not to use them. And to me, I don't like them. These are almost like default values in some ways, right? How often do we need it? I'm going to stop there. How often do we need those, or do I see them in practice? Very, very, few times. Very, seldom do we use these kinds of constructs. Why? They're ambiguous. Imagine if you have a massive class, right, that has many, many, many properties. What the hell are constructor initializers going to do for me? I'd have to write colon blah 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 blah. It's me like the whole thing, right? It makes no sense. I'd rather write a method, an initializer method, that I initialize certain properties, right? That makes more sense. Sometimes, I told you before, we might have features to a class or features to a programming language. They're neat features, but I'll never use them. But they're features because some people need the flexibility to work out a problem. Remember, each of these features have been designed to solve a problem. For someone had a problem, and so somewhere down the road, they created a feature for the language to solve that problem, a workaround sometimes. Sometimes they're good workarounds. In this particular case, it's a bad workaround, right? But I'm telling you about them, just like we talked about reference variables last week. I said, don't use reference variables, right? It's bad. It's true. You could do it, right? But it's silly to use. It's like you're eliminating your control, and you're increasing your chances of having errors. Let's take a brief break.